Now let us quickly discuss one more problem. Problem set 2.7, solution to 2.105. Now it is a problem from friction. Engineering Mechanics by Timoshenko and D.H. Young. Now look at the statement and the diagram. A short right circular cylinder. Look, this is a right circular cylinder. And this is the side view, right? This cylinder is same thing as this one, right? When seen from this side, it appears like this, right? And this one is this wedge when seen from this side. So a short right circular cylinder of weight W vertically downward, acting vertically downward. It is resting on a horizontal V-shaped notch. This V-shaped notch on which this cylinder is resting. So there is a point of contact here and point of contact here. So there will be reaction force here and here. There will be two reaction forces. And this V-shaped notch on which this cylinder is resting is shown here like this from the side view. And when you are pulling this cylinder to this side with a force P, there is a point of contact here and a point of contact here. So along this horizontal line, one on this side and on the other side at the same level, here there will be two forces of friction. Having angle 2 alpha as shown in figure D, if the coefficient of friction is mu, find the horizontal force P necessary to cause slipping to impede. Now given this angle is alpha, now look at the cylinder is resting on two inclined supports. This is one inclined support of the V-shaped notch. Therefore, two normal reactions Rn making angle alpha with the horizontal. How Rn makes angle alpha horizontal with the horizontal, I will explain in the next diagram here. The same diagram is drawn here. Here, the cylinder will have some action force to this side. So this is the normal reaction. Here, the cylinder will have some action force. So this is the normal reaction. This angle and this angle both are given as alpha. I can later on translate this Rn to this point and show it here. And I can translate this Rn to this side and show it here. Now look at this portion. This line is same thing as this line. This line is same thing as this line. Since this angle is alpha, that is same thing as this angle alpha, which I have shown it here. And this normal reaction, which is here, Rn, I have translated to this side. Normal, so for this angle is 90. This is given as alpha. So in this triangle, we are left with 90 minus alpha. This angle is vertically opposite to this, so this will be 90 minus alpha. Here this is your x-axis, this is your y-axis, so therefore this is your alpha. So Rn, when translated to this point, makes angle alpha with the horizontal. Similarly, this Rn, when translated here, will make angle alpha with the horizontal. So that is what I have shown in the next diagram. So this is your Rn, alpha, alpha. Now let us apply sigma y is equal to 0. The component of this Rn and the component of this Rn along positive y-axis, if you draw perpendicular, there will be 2Rn sine alpha that is being opposed by W in equilibrium. So 2Rn sine alpha is W, so Rn is W over 2 sine alpha. Make it equation 1. Then apply sigma x is equal to 0. Now look at the front view. Look at the front view. This is the pulling force P at this point of contact and at this point of contact. When this cylinder is pulled to this side along this horizontal line, and on the other side at this point of contact there will be again a horizontal line at which the cylinder is trying to slide. So look at the front view. Two forces of friction will act horizontally at the point of contacts. Now sigma x is equal to 0 means this is the pulling force, and the force of friction will be to this side, and for one surface, and on the other side for the other surface. So there are two forces of friction. So P is equal to 2 times F, and as we know, force of friction F is equal to mu times normal reaction. Therefore, we'll put this value of here in this expression. We'll put the value of Rn from equation 1, which was W over 2 sine alpha. W over 2 sine alpha. So your P becomes 2 mu value of the normal reaction Rn, W over 2 sine alpha. So this comes out to be 2 cancels. So mu W over sine alpha is the pulling force when it is just about to move. The value of the pulling force is equal to coefficient of friction times the weight of the cylinder over sine of the angle alpha.